Solve for x. So we're looking for the unknown. We're looking for that variable. So if it helps you understand, you can make up a little story. So let's say that we had a pile of sugar on the scale to start with, and I don't know how many scoops that is. But I know that after I take away 8 scoops, then it has 18 left. So on a scale, the weights on the right hand side shows me, okay, that's weigh 18 scoops, right? So we want to figure out how many scoops of sugar it was started with that pile, okay? So now I know that, just imagine this. You had a big pile, you took away 8 scoops, and the scale is balanced. So to find out how much it had originally, don't you have to put back the scoops that you took away? So to put back, mathematically, it's adding, right? So you put back the 8 scoops. Okay, now, but think about this. The scale was balanced after you took away the 8. But now you put back 8, it's not balanced anymore, right? One side is heavier than the other side. So what would you do to make it balance again? Well, you would do the same thing on the right hand side. You would put back 8 scoops also. You would add 8 scoops also on the right hand side, right? So now the equation is balanced again. So now after you put back the 8 scoops, right? You took away 8 and then you put back 8, then you would have what you started with, that big pile, right? Nothing was less, nothing was more, because you put it back. So now you read a scale again, and it's also balanced, right? It was balanced. Now you read a scale again, you go, okay, now it's worth 26 scoops, right? So there's your answer. You found how much you had to start with, right? So this is how we solve an equation, and because we only use one step here, so that's why we call this a one-step equation. Now, to check if we were right, we can do a quick check here. We would then replace this solution that we found. We would replace the variable to begin with the solution that we found here. So we're saying that, okay, I did have 26 scoops to start with in that big pile. After I took away 8, would that make my scale balance, right? So what is 26 minus 8? Okay, that's 18. Oh, it does equal the right-hand side because 18 and 18 are the same. So that tells me that is the correct solution. That's how we check. Okay, so let's look at another example. X plus 5 equals 12. Now this time try not to use a story. Let's just look at it mathematically. But you can relate to what we did before. When we had the takeaway, we added. So we're undoing the takeaway, right? And here we're going to do the same thing. Because we added 5, we're going to undo the adding. What undo? What would undo the adding? Subtracting, right? So we'll do that. But because we want to keep the scale the same on both sides, we want to balance the equation, we would do the same operation on both sides. Okay, so if it helps, you can draw a line in the middle to tell you that this is the left-hand side and that's the right-hand side. Okay, so after you add and subtract, they undo each other, so you only have x left, which is what we want. This is our goal, right? Our goal is to solve for x. So we want x all by itself on one side. On the right-hand side, we have 12 minus 5, which is 7. Okay, I almost said 6. So, oh, you know what? Let's try that. Let's say that I accidentally did 6. Okay, so then when I check my answer, what would happen if I had a wrong answer? Okay, so we're gonna say, okay, I got 6 as my answer. So I'm replacing this x with 6, right? So we have 6 plus 5. And I want to see if that would balance the right-hand side. Would it? Well, 6 plus 5 is 11. It is definitely not 12. So that tells me, okay, this 6 is the wrong answer. Okay? So now, so then we double check. Okay, 12 minus 5. Oh, it should have been 7. Well, let's check again. If I replace the x with a 7 instead, okay, so then I would have 7 plus 5. Would it be the same as the right-hand side? Would it balance the right-hand side? Yes, because 7 plus 5, if you put it in the calculator, you get 12. Okay, it's exactly the same as the right-hand side. So that tells me then the x equals 7 is the right answer. Okay, so now that's the idea. We will first undo something, and then to get variable all by itself, and we will then check. That's the basic process of solving an equation. So look at another example, part C. 4x equals 24. So like we said before, the goal is to get this variable x all by itself. I don't care about anything else. I just want x, right? So your answer should look like x equals something, right? So to help, we can put a line in the middle so we know that left-hand side and the right-hand side have to be the same, right? Okay. So on the left-hand side, 4x. So as we mentioned before, this is a coefficient, so 4x means 4 times x, right? So to undo multiplying, what would undo multiplying? Well, dividing, right? So we will divide 4, and don't forget, in order to balance, we'll do the same thing on the right-hand side. We're dividing, okay? So when we have 4 divided by 4, then we know, well, 4 divided by 4 is 1, right? So that would give us 1x. Now, because 1x is the same as x, because 1 times anything is just that anything, right? We can kind of cross it out here to just say that, oh, that kind of, they cancel each other out, some people might say. So on the right-hand side, we have 24 divided by 4, which is 6, okay? So to wrap up our answer, x equals 6. That's our solution. And we'll do a quick check here. So if I replace the x with my solution, I'll have 4 times 6. And I want to see if it turned out to be 24. Does it? Yep, because 4 times 6 is 24. And the right-hand side is also 24. So they equal. So that tells me that's the right answer. Okay? So now one thing I want you to notice now is that if you have add and then subtract, then they would, when they undo each other, if you add the same number and then subtract the same number, then it would result in a 0, right? So in part C, in this example, when you have something that's multiplied and then you divide by the same number, then it's going to result in 1, right? So, okay, so that's a side note. Now let's look at another example here. So same process. The goal is to get x all by itself on one side. And we want to balance the left-hand side and the right-hand side. The first step is to undo whatever is attached to the x. So in this case, it's dividing by 4. What would undo dividing? Well, multiplying the same number. Okay, so we'll do that on both sides. So like we said before, if you divide and then multiply, it will result in just 1. Okay, so 1x, that's what's left. And then on the right-hand side, 8 times 4 is 32. Okay, so basically your answer is x equals 32. do a quick check. If I replace the x with 32, divided by 4, does that balance the right-hand side, which is 8? Yes, it does, because 32 divided by 4 is 8, and the right-hand side is also 8.